Welcome to Skills Staircase, your guide to mastering the fundamentals of technology. This is the first step on our journey, and we're starting with an absolute bedrock of all digital communications, the network models. Have you ever wondered how an email you send from your laptop travels across the world to your friend's phone? No, it's not magic. It's a highly structured, step-by-step process, and the blueprint for that process is what we call network model. In this video, we're going to demystify the most important models in networking, the OSI model and the TCP IP model. By the end of this, you'll have a clear foundational understanding of how data moves across any network, which is essential for anyone in IT or cybersecurity. Imagine a world where every phone company used a different language. You could only call people who use the same brand of phone as you. And that's what networking was like before these models. The core problem was the Tower of Babel effect, incompatible systems. A computer made by, say, company A couldn't easily talk to a server made by company B. And to solve this, the industry needed a common language, a universal set of rules. That's where the concept of layered network models come in. It breaks down the incredibly complex task of sending data into smaller, manageable, and standardized steps. Each step or layer has a specific job, and it only talks to the layer directly above or below it. This modular approach is the secret to the internet's success. First up is the OSI model, or Open Systems Interconnection model. Think of the OSI model as a textbook definition of networking. It's, it's a theoretical seven-layer framework developed by the International Organization for Standardization. What a mouthful. So it's ISO, ISO. While it's not the model that runs the internet today, that's the TCP/IP model, which we'll come to in a bit. It is the one we use for teaching, troubleshooting, and understanding network concepts. It's the most detailed and comprehensive way to look at the process. I mean, to remember the seven layer in order from top to bottom, we use simple mnemonics, if I can say that word properly. One of them is please do not throw sausage pizza away. So that's the top to bottom. But if you prefer the other way and you want to go from bottom to top, then you can always do people seem to need data processing. Trust me, I've heard many different variations of this, and you can also create your own one. But it does help in remembering these layers. Let's now start at looking at these layers. We start at the top, the layer closest to the user. These are the upper layers. Layer 7, the application layer, is what you interact with. This is where your web browser, your email client, or your file transfer program lives. It provides the interface for network services. Layer 6, the presentation layer. It's all about the data format. It ensures that the data sent by one system is readable by the receiving system. It handles things like encryption, decryption, and compression. Think of it as the universal translator. Layer 5, the session layer. This manages the communication session itself. It's responsible for setting up, coordinating, and terminating the conversation between two applications. It ensures that if a connection drops, it can be resumed from the last checkpoint. Now we hit the most critical layer of our discussion. Layer 4, the transport layer. This is the heart of end-to-end communication. Its main job is to break the data from the upper layers into smaller, manageable chunks called segments, and then reassemble them correctly on the other side. It also determines the reliability of the connection. Here we meet two famous protocols, TCP and UDP. TCP is like sending a registered letter. It's reliable, it checks for errors, and it ensures that every piece arrives in the correct order. UDP, on the other hand, is like shouting across a crowded room. It's fast, but there's no guarantee that the message will be heard or that all the parts will arrive. TCP is used for web browsing and email, while UDP is used for streaming videos and gaming, where speed is more important than, than guaranteed delivery. Finally, we move into the lower layers. The lower layers, which handle the physical movement of data. Layer 3, the network layer. This is responsible for routing. It uses logical addresses, specifically IP addresses, to determine the best path for the data to travel from the source network to the destination network. This is where routers operate. Layer 2, the data link layer. This handles the communication within the same local network, uses physical addresses or MAC addresses to identify devices. It also packages the data into units called frames and detects the errors that occur in the physical medium. At the very bottom is layer 1, the physical layer. This is where the hard At the very bottom is layer 1, the physical layer. This is the hardware, the cables, the Wi-Fi signals, the network interface cards. Its job is simply to transmit the raw, unorganized streams of bits, the ones and zeros, across the physical medium. Now let's talk about the model that actually powers the internet, the TCP/IP model. While the OSI model is great, a theoretical tool, the TCP/IP model is the practical, real-world standard. And it's named after the two most important protocols, TCP, which we just discussed, and IP, the Internet Protocol. Unlike the OSI 7 layer, the original TCP/IP models has only 4 layers. It's a simpler, more streamlined approach. The biggest difference is that the TCP/IP model combines several of the OSI's functions into single layers. This makes it more efficient for implementation, which is why it's become the dominant standard. Let's see how the two models stack up against each other. This is a crucial concept to grasp. The OSI's model's top 3 layers, application, presentation, and session, are all combined into a single application layer in the TCP/IP model. This is because, in practice, these functions are often tightly integrated within the application itself. The OSI transport layer remains the transport layer in TCP/IP. The OSI network layer becomes the internet layer in the TCP/IP model, which is primarily connected with IP addressing and routing. And finally, the OSI's data link and physical layers are combined into the network access layer in the TCP/IP model. This layer handles all the physical details of getting the data onto the wire and over the air. To understand these models, you need to know about encapsulation. Think of it like sending a letter. When your application sends data, it starts at the top layer. As the data moves down the stack, each layer adds its own control information, called a header. The header is added to the front of the data. This is like putting the letter into an envelope and writing the address on it. The data changes name as it moves. At the transport layer, it becomes a segment or datagram. At the network layer, it's a packet. And at the data link layer, it's a frame. Finally, at the physical layer, it's just streams of bits the ones and zeros, ready to be transmitted. When the data arrives at the destination, the reverse process happens. Decapsulation begins. This is like the recipient opening the letter. The data starts at the physical layer, and as it moves up the stack, each layer performs its check, verifies the header information, and then strips the header before uh, passing the data up to the next layer. For example, the network layer checks the IP address to ensure the packet is for this device, and then it removes the IP header and passes the segment up to the transport layer. This continues until the data reaches the application layer, where it is finally presented to the user's application in its original readable form. This elegant layered process is what makes reliable communication possible. To quickly recap, the most important points from this foundational lesson: the OSI model is your conceptual map, the 7-layer reference model that helps understand and troubleshoot every step of communication process. The TCP IP model is the practical engine, the 4-layer standard that is actually implemented on the internet today. Both models rely on the principle of a layered approach, which allows different technologies to work together seamlessly. And remember the concept of encapsulation, where data gets wrapped in headers as it travels down the stack, changing its name from data to segment to packet and to frame. And that kind of brings us to the end of our first step on the skills staircase. We hope this explanation has clarified the fundamental differences between OSI and the TCP IP model. And if you found this helpful, please take a moment to like it, subscribe it, and your support helps us build more foundational content like this. And ready for the next episode, if you will, we'll be talking about the TCP IP basics for security engineers, which kind of goes into the packet flow, the IP addressing, and the routing. Thank you for joining us, and hope to see you in the next one.